I want you to do something right now, if you can. Just hold up your hand and look at it. Wiggle your fingers.
Touch your thumb to your pinky.
Yeah, exactly. It feels completely effortless, right? You don't even think about the mechanics of it.
No, not at all.
But underneath your skin, I mean, there is this absurdly complex network of levers and cables and, these high-definition sensors all firing in perfect real-time harmony.
It really is an engineering marvel. You're looking at like milliseconds of data transmission.
Right.
You've got these micro adjustments of tension happening instantly and a structural stability that somehow balances with extreme flexibility.
So what if the exact biomechanics of your fingers, your tendons and your nerves held the ultimate blueprint for running a highly agile business or even managing a hospital?
It sounds like a stretch at first, I know.
Yeah, but we're not talking about like a poetic metaphor to use at some corporate retreat. We are doing a deep dive today into a highly original, incredibly detailed framework that Dr. Christophe Delong and Kinexa Formation present.
It's fascinating stuff.
Right. Our mission today is to decode this theory because they're basically mapping the human body, the mechanics of sailing a boat, and modern corporate strategy into one single cohesive model.
Yeah, they call it neurobiomechanical piloting.
Neurobiomechanical piloting.
All right. And the core argument from Dr. DeLong and Kinexa Formation is that true organizational performance can't just resemble a machine anymore.
Because machines are too rigid?
Exactly. A mechanical machine is way too rigid for modern markets. So a highly functioning organization actually has to mimic a biological organism.
And how do they do that, practically speaking?
Well, it achieves this by using artificial intelligence and technology, specifically Kinexa's algorithms, to act as this highly tuned nervous system, one that can detect, the absolute faintest weak signals in the environment.
Okay, let's unpack this. To understand this living organization, we have to start with the anatomy of strategy, right? The source material maps the human hand directly onto a corporate structure.
Right, it's a direct mapping.
So let's start at the very edge, the fingertips. In the framework, these are called the distal phalanges.
Yeah, the distal phalanges. In human anatomy, the pulps of your fingertips are just packed with these sensory receptors. They're called Meissner and Pacini corpuscles.
Pacini corpuscles, got it.
Right, and they are incredibly sensitive to high-frequency microvibrations. So when you touch a surface, they don't just register like hard or soft.
It's way more nuanced than that.
Exactly. They instantly transmit texture, microscopic friction, shifting pressure all straight to your brain.
Wow. So in a corporate body, those fingertips, those sensors,
Yeah.
those are your frontline workers.
You got it. Your field sales team, your customer support agents, the people on the factory floor,
Yeah.
or, even the IoT data sensors you've deployed in the supply chain.
So their primary job isn't just to execute tasks. According to this framework, they are literally high-definition sensors.
Their fundamental purpose is to detect the microvibrations of the market.
Like a shift in consumer mood.
Exactly. A frontline worker might sense a slight shift in the mood of the buyers, right? Or a logistics manager might notice this tiny recurring friction point in a supply route.
You feel it first.
Right. They feel these anomalies long before those vibrations compound into full-blown crises that show up on a quarterly earnings report.
Okay, so the front line reads the market. But wait, let's look at the thumb, because the source specifically points out the eminence thenar.
Yeah, the fleshy part at the base of the thumb.
Right, as being crucial for executive leadership. The thumb provides opposition, which gives the hand its stability. But if the thumb is the CEO, providing that stable base, but what happens when you try to pick up a tiny, delicate pin without moving your thumb at all?
You can't. It's incredibly awkward.
Exactly. Actually, wait, doesn't a thumb that is entirely rigid just get in the way of agility? If the executive leadership absolutely won't move or adapt, the frontline fingers are just like flailing around without anything to press against.
That is such a good point, and the framework actually anticipates that exact structural failure.
Oh, really?
Yeah. That is why Dr. DeLong's model emphasizes the joints over the pure force of the bone.
Okay, joints over bone.
Right. The thumb relies on the trapeziometacarpal joint. It must be stable, yes, but it must also pivot.
So if leadership is pure rigid bone,
the organizational structure shatters under pressure. The framework argues for agile governance. You need the stability of the strategic vision to hold attention, sure, but the joint itself must be flexible enough to allow the fingers to do the delicate, responsive work.
Which brings up the transmission of that force. Because, fun fact, there are no actual muscles in your fingers.
Right, it's all tendons.
Yeah, the power to grip actually comes from the forearm. So how does a strategic decision actually travel from the top down to the fingertips without losing force? The framework points to the flexor tendons, right? Running down the arm.
Yeah, the flexor digitorum. These act like high tensile cables.
Right, tensile cables.
Right, the actual muscle power is generated back in the forearm, but the tendons transmit that mechanical power all the way to the distal phalanges.
So in a business, these tendons are, what, middle management?
Exactly. They are your workflows, your internal processes, and your middle managers. They don't generate the raw strategic energy that comes from the core muscle, and they don't feel the delicate market vibrations like the fingertips do.
But they connect the two.
Yes, they are absolutely vital for transmitting energy smoothly to the front line. Because if a tendon is weak, the finger cannot grip no matter how strong the forearm is.
That makes perfect sense. But, a hand doesn't just sit there in a vacuum flexing its tendons. It interacts with chaotic environments. The market is never still.
Never.
So to explain how a corporate hand actually moves and reacts to unpredictable pressure, the framework steps out of the anatomy lab and puts us on a sailboat in the middle of the ocean.
Which is such a brilliant pivot because the physics of sailing align perfectly with market dynamics.
Because the wind is unpredictable.
Exactly. In sailing, dealing with the wind is dealing with a chaotic, invisible, and constantly shifting force. So to manage it without capsizing, sailors use a practice called trimming.
Right, because you don't just hoist a sail, tie off the rope, and hope for the best. You have to constantly manipulate the tension.
Trimming involves continuous millimeter-level adjustments. The source text refers to these as micro-relâchés and micro-reprises.
Which translates to what, like micro-releases and micro-pulls?
Yeah, tiny calculated releases and tiny deliberate pulls on the ropes. The sailor watches the pennons, those little telltale pieces of yarn attached to the sail that show how the air is flowing.
Ah, right, the pennons.
But more importantly, the sailor is actually feeling the aerodynamic tension of the rope directly in their hand. The hand is literally acting as a biometric sensor.
Reading the wind's pressure through the rope.
Exactly, and making instant micro-corrections to optimize the boat's speed.
But here's where it gets really interesting. In a modern corporation, the data flow is way too massive and too fast for a human manager to feel every single vibration.
Oh, absolutely. It's overwhelming.
Right. Like, if a company operates globally, there are millions of pennons fluttering all at once. And this is where Kinexa's technological optimization comes into the picture.
Right. Kinexa's algorithms act as a highly calibrated artificial nervous system. The AI automates the massive influx of decision flows and predictive analysis.
So it's crunching the data.
Yeah, it takes raw, chaotic market data like global supply chain delays, real-time consumer purchasing shifts, competitor pricing fluctuations, and it converts all of that noise into a clear neurological signal. It calculates an actionable trajectory.
So if you're listening to this and you're managing a team right now, you might be wondering, does handing this over to Kinexa's AI, you're just putting your business on autopilot, like, are we taking the rope out of the sailor's hands entirely?
That's the fear, right. But the framework specifically rejects the idea of total replacement. It describes the ideal organization as a hybrid organism utilizing a double-loop system.
A double-loop system. Walk me through that.
So buccal 1. The first loop is the AI. It provides the high-definition sensory input, filtering the noise, detecting the weak signals, and predicting the gusts of wind before they even hit the sail.
Okay, so the AI is the sensors. What's buccal 2?
Buccal 2 is the human element. The human provides the strategic adjustment, the nuance, and the final arbitration. The AI doesn't replace the sailor. It acts as, like, cybernetic fingertips.
Cybernetic fingertips, I love that.
Yeah, it reduces the cognitive load of processing raw data so the human operator can focus entirely on the precision of the strategy.
So the AI filters the noise, and the human only feels the pure signal. And, the text mentions a specific physical technique sailors use that maps brilliantly to modern business strategy. Interdigital dissociation.
Yes, interdigital dissociation. Think about the mechanics of holding a thick, heavy rope under extreme tension.
Okay, I'm picturing it.
You grip it tightly with your pinky and your ring finger. That is your base power grip, managed biologically by the ulnar nerve.
Right, the ulnar nerve handles the power.
But while you are holding that massive foundational tension, you simultaneously use your thumb and index finger, which are managed by an entirely different nerve, the median nerve, to make tiny, precise adjustments to a secondary line.
Wow, so you're isolating different parts of the same hand to do completely different jobs. You hold the core structure with one side and tinker with the other?
Exactly. In a corporate setting, interdigital dissociation is the ability of an organization to hold the main rope tightly. Meaning, you maintain your business fundamentals, you protect your core revenue streams, you keep the legacy product stable.
That's your pinky and ring finger, your ulnar grip.
Right. Simultaneously, you use your agile fingertips, your median nerve, to make highly precise experimental adjustments for innovations, R&D, or entering new markets.
So you don't have to let go of the main rope, risking the whole boat just to tinker with a new strategy.
Exactly.
But so, what does this all mean when things go wrong? If the company is constantly adjusting to this chaotic wind, constantly tweaking the innovation line while holding the massive tension of the legacy business, what prevents the whole structure from tearing itself apart?
That's the million-dollar question.
Right, like a sudden macroeconomic storm hits the market, the wind howls. How does the corporate hand not break its own fingers?
Well, biological bodies have built-in survival mechanisms for sudden violent shocks. And the most critical one adapted into this framework is the myotatic reflex.
The myotatic reflex, that's a biological reflex where a muscle instinctively contracts in response to being suddenly stretched.
Exactly. The signal doesn't even travel all the way to the brain to be processed. It loops through the spinal cord and goes right back to the muscle in milliseconds.
So it bypasses conscious thought entirely for the sake of speed.
Yes, for survival speed. Dr. DeLong's framework dictates that modern companies must build these exact same autonomic reflexes into their digital and operational structures.
Because if you wait for a human to approve it,
You're too late. If you wait for a data point to travel all the way up to the executive brain for processing during a crisis, you are already too late. You need automated protocols, built-in structural redundancies, and AI-driven safety nets.
what does an automated myotatic reflex actually look like, in a company software stack?
Let's say a critical component in your supply chain suddenly fails. A port shuts down unexpectedly.
Oh, man.
Right. The muscle of your supply line is suddenly stretched dangerously thin. An automated myotatic reflex in your logistics software detects that anomaly and instantly reroutes inventory from a backup warehouse.
It just does it.
It stabilizes the system in milliseconds. The frontline teams in the automated systems react and brace the structure before the CEO even has time to schedule a crisis meeting.
That is wild, but that level of autonomous reaction relies heavily on the underlying architecture holding together, which introduces the concept of tensegrity, tension plus compression.
Right. Tensegrity is this architectural and biological principle. A healthy system balances elements that are rigid and under constant compression with elements that are highly flexible and under continuous tension.
So in human anatomy, your rigid elements are your bones.
And your tension elements are your muscles and tendons. On a sailboat, the mast is under compression, while the shrouds and ropes are under tension.
Okay, so map that to a company for me.
In a company, your rigid bones are your compliance laws, your governance, and your core financial guardrails. Your flexible tendons are your company culture, your decentralized communication networks, and the adaptive skills of your people.
Okay, so what happens if that balance is off? Because if you are sitting in a Tuesday morning meeting and you feel like your entire department is completely paralyzed by red tape, endless approval processes, rigid hierarchies, you aren't just experiencing a generic lack of efficiency. According to this model, your organization literally has carpal tunnel syndrome.
Yes, the framework uses carpal tunnel as the exact pathology for bureaucratic failure. Physiologically, carpal tunnel syndrome occurs when there's too much structural pressure in the wrist.
Right, which pinches the nerve.
Exactly, the median nerve becomes severely compressed. The information is trying to flow from the sensory fingertips to the brain, but the inflammation pinches the nerve. The hand goes numb.
And in a corporate structure?
In a corporate structure, that inflammation is excessive bureaucracy. When middle management, the tendons becomes inflamed with endless reporting requirements and rigid KPIs, it chokes the flow of data.
Wow.
A numb company cannot feel the micro-vibrations of the market. It drops the rope.
It drops the rope. But the flip side of that inflammation is the buildup of calluses, right? When hands experience a lot of physical friction, they build up thick calluses to protect the underlying skin.
Yeah, it's a defense mechanism.
So experience in a corporate environment acts exactly like a callus. It protects the organization from the daily grinding friction of the market.
It does. But if that callus gets too thick, you lose your sensory interface. Think about the seasoned veterans at a company who say, Well, we have always done it this way.
We've all heard that.
Right. They have built up such a dense callus of institutional experience that they can no longer feel the weak signals of a changing market. The new data simply cannot penetrate their thick skin.
So how do you fix that?
Well, the training programs designed by Kinexa Formation aim to maintain the perfect thickness of that interface. The organizational skin must be robust enough to survive the operational friction, but thin enough to allow the neurological data to pass through instantly.
You know, this neurobiomechanical model sounds incredibly sleek when applied to a tech startup or a logistics firm. But the source material doesn't stop there. It takes this theory and throws it into the absolute ultimate stress test, healthcare and hospital management.
Oh, yeah, which is an environment of literal life and death, not just profit margins and market share.
Right. And a hospital is arguably the most complex, high-stakes organization in existence. It is the perfect crucible to test the limits of this theory. The framework views the hospital institution itself as the mast of the ship.
Yes, the mast.
A mast is the rigid bone, it's the spine. A hospital has to be incredibly rigid when it comes to safety protocols, sterile environments, medical ethics. I mean, if I'm on an operating table, I don't want a flexible interpretation of surgical protocols.
That's not like.
I want rigid, unyielding rules. I want a mast that does not bend.
And it's a completely natural reaction to want total rigidity when lives are on the line.
Yeah.
But the framework counters this by distinguishing between the specific medical gesture and the overarching management system.
Okay, so the gesture versus the system.
Right. The surgical gesture must be infinitely precise, but the system managing the hospital's resources must be adaptable. In sailing and in healthcare, if a mast is perfectly rigid, it will snap during a hurricane.
Ah.
A properly engineered mast is designed to sinter, to bend and bow slightly under extreme anomalous pressure.
Such as a sudden mass casualty event
Yeah.
or a global pandemic causing a massive influx of intensive care patients.
Exactly. The hospital mast must absorb the operational overpressure without breaking. Rigidity in a dynamic crisis is what causes the structural failure.
Like running out of ICU beds because a rigid protocol won't allow administration to quickly repurpose another ward.
Yes. Survival requires agile governance. The thumb provides the stable anchor of medical standards, but the joint must allow the hospital to pivot its resources.
And the people transmitting those resources, the nurses, the doctors, the orderlies, they are the tendons. They are the flexor digitorum of the healthcare system.
They are. And just like we discussed carpal tunnel in the corporate world, if those medical staff suffer from severe burnout, the framework views that as a literal physiological inflammation of the system.
Wow, so burnout isn't just an HR problem.
No, burnout isn't framed as a secondary human resources issue. It is a primary biomechanical failure. Inflamed tendons lock up the entire joint of the hospital. If the nursing staff is inflamed with exhaustion, the transmission of care stops completely.
No matter how brilliant the doctor's brains are, or how structurally sound the hospital's mast is.
Exactly. The joint locks.
The precision of that medical gesture you mentioned earlier, it brings us right back to the fingertips, doesn't it? The diagnostic hand.
It does. For a surgeon or a registered nurse, their actual physical fingertips are high-definition sensory interfaces. When a nurse is palpating a patient's abdomen or feeling for a subtle vein, they aren't just touching skin, they are reading the biological penance.
The telltales of the human body.
Yes, they're feeling tissue tension, microscopic shifts in pulse rhythm, localized changes in heat.
It is the sailor reading the wind, but the wind is the patient's biology.
Beautifully put. And just like Kinexa's AI helps the corporate sailor filter market noise, advanced robotics and AI-driven imaging act as cybernetic enhancements for the surgeon's hands.
Which requires that same interdigital dissociation. The strong holding force of the thumb to stabilize the robotic instrument, and the micro-adjustability of the flexors to make a millimeter incision.
Absolutely. The ultimate synthesis of this model, whether it's being applied to a hospital operating room or a corporate boardroom, is achieving what Dr. Delong and Kinexa Formation call la main totale.
The total hand.
The total hand. It is a state of organizational being where every single actor, from the executive leadership holding the governance anchor to the frontline data clerk interacting with the customer, isn't just a passive tool following a flowchart.
They are active, integrated sensors in a living network.
Exactly. A total hand organization feels the wind through its operational extremities and adjusts its deep internal structure instantly and instinctively. It is the absolute fusion of human biomechanics and technological optimization.
Tomorrow, when you log on or walk into your workplace, I want you to audit your environment through this lens. Are you the thumb, holding the stable strategic vision and providing the foundational anchor? Are you the tendon, transmitting the force of middle management and trying desperately to avoid catching fire from the friction of bureaucracy? Or are you the highly sensitive fingertip, feeling the real-time pulse of the market, hoping the organizational brain is actually equipped to process your signals?
It really completely changes how you view your daily operational frustrations. That persistent bottleneck in your logistics department isn't just an annoyance. It is an inflamed tendon threatening the grip of the entire company.
Right.
That disconnected executive team isn't just aloof. They're a thumb that refuses to pivot its joint, rendering the delicate work of the fingers utterly useless.
It is an incredibly powerful structural way to diagnose a company's health. But I want to leave you with one final provocative thought to mull over, something this deep dive kind of circles around.
Okay, let's hear it.
If we are actively engineering our companies, our software stacks, and our hospitals to behave exactly like biological organisms, if we are installing AI algorithms to act as a literal nervous system, treating data flows as a circulatory system, and coding automated myotatic reflexes that intentionally bypass human analysis for the sake of speed, at what point does a corporation functionally stop being a constructed machine and start operating as a literal autonomous living organism?
That is a wild thought.
Right. If it feels the wind on its own and it flexes its own digital muscles to survive without you telling it to, what exactly have we built? The next time you hold up your hand and wiggle your fingers, ask yourself in the corporate body who is actually pulling the strings.